We're going to talk about 18.5, writing formulas. With polyatomics. Now, we've been looking at polyatomics with our warm-ups, and we did a polyatomic worksheet and all that good kind of stuff. So this is the next section in our nomenclature book. The idea of a polyatomic ion is that poly means many and atomic means atom. So we have many atoms. And the idea is that this is atoms coming together, and they come together almost like a compound, but what happens is that we get a leftover charge. So what's going to happen here is that in order to write our formulas for our polyatomic compounds, you're going to use your polyatomic sheets. Now, those sheets, of course, we put at the back of your nomenclature book. So use those as reference. And the other thing we should point out is, like, how do you know when you have a polyatomic compound? So you have a polyatomic compound. When, and the whole idea is the ending. So, if it ends in ATE, ITE, and then we do have two ides, but there's only going to be two, so you just have to watch out for these two words. Hydroxide and cyanide. So those are both, or those are two ides that are going to tell you have a polyatomic, or if it ends in ate or ite. So the key is in the ending. So when we start getting everything all mixed up together, you're going to start looking at the endings and determine if you have a polyatomic compound. Alright, so let's start looking at some examples here. And talk about how to actually... Alright, so these rules here, let's see, let's come up with a good example. Let's try calcium. And let's put that with cyanide. Now, the good thing is that basically you've already learned the rules on how to do these because they're just like your type 1s and 2s. We just have to add a little extra rule in here. So, I know I have a polyatomic because look at the second word. Now, granted, it ends in "ide," but it's one of the exceptions. So, cyanide, so CN 1 minus. You could find that on your sheet. That's all I did. I went to the polyatomic sheets. I looked up cyanide, CN with a 1 minus charge. Now, the first name in the word should show up on your periodic table. Calcium, it's in that second column, so Ca, 2 plus charge. All of these are going to have charges. So, we find the symbols, we find the charges, just like our type 1s and 2s. Once you find your charges, what you're going to do is see if you can reduce them, just like your type 1s and 2s. This is not able to be reduced. And then what you're going to do from here is you're going to go ahead and you are going to cross the charges. I'm going to start over here with my polyatomic with the 1. The 1's going to come down here. Now, Remember that we write calcium, and it technically would be a 1, but we don't like 1s, so we don't write the 1s. Now, the 2 is going to come down here. Anytime you are crossing a number to a polyatomic that is larger than a 1, you need to put parentheses around your polyatomic. So, this would be parentheses CN2. We do that for 2 reasons. One, so that this 2 distributes to both the carbon and the nitrogen. The other reason we do that is so, this is not a great example of it, but if let's say that nitrogen had a number after it, you don't want to put 2 numbers right next to each other. So those would be some reasons why. You only use the parentheses though if you're crossing down a number that is greater than a 1. So, for example, if I was doing a problem like, gold for sulfate, again, here's a good example of a traditional polyatomic. It ends in 8. So you go to your sheet, you look it up. Sulfate is SO4 with a 2- charge. Keep in mind, too, that all of this is one piece. It stays together. Think of this as all together. It doesn't separate. Okay? And then we have gold, which is AU. And we have the charge of a 4+. Now, first thing you're going to do, right, is reduce those charges down. They're both divisible by 2. So that makes that a 2. That makes that a 1. So, we're going to cross down the 1 to the gold. So, AU with a 1. And then the 2 goes down to the sulfate. But again, you're crossing out a number larger than a 1. So, SO4, 2. So here's a prime example of why we need the parentheses as well. Not only does that 2 have to apply to both the S and the O, but look, you don't want the 4 and the 2 right next to each other. If you didn't have the parentheses, it'd look like 42, and that wouldn't look right. All right, let's try a couple more. What about just like sodium hydroxide? Okay, so again, hydroxide is one of the exceptions to the rule. We look that up. It's an OH with a 1- charge. And then you have sodium, which is in the first column. It has a 1+ charge. There's no reducing here, right? We're just going to cross away. Now, look at this, though. The 1 comes down here like before. And no single element will ever get a parenthesis. So even if that was a 2 or 3 or whatever, you don't put parentheses. But we have a 1 here that's crossing down the polyatomic. If it's a 1, there's no parentheses. Just write it down, whatever it is. Okay? So there's some examples of how to do writing formulas with polyatomics.